Good morning, all of you. Today we will see the continuation for this one. It is nothing but anti-Marconi curve rule. Anti-Marconi curve rule. Today we learned under unsymmetrical alkene. Addition of hydrogen halide to unsymmetrical alkene. Two rules are following. One is Marconi curve rule, another one is anti-Marconi curve rule. So what is the anti-Marconi curve rule we will discuss? First of all, you take one example. It is nothing but CH3, CH double bond CH2. Okay, first of all, you have to understand one thing. This anti-Marconi curve rule will work out with addition of HBr. Will not work out with HCl and HI and HF. So anti-Marconi curve rule you are doing is compulsory we should add HBr. Why? Because the entire process will be the exothermic phenomena, means while breaking and formation, energy will be releasing in case of HBr. That's why HBr will be following an anti-Marconi curve rule. Another thing, it is compulsory worked out in presence of peroxides. I think you have some idea regarding peroxide. Peroxide means what? Two oxygen atoms are directly connected together. Such linkage having compounds is calling as a peroxide. Means peroxides. Okay. First of all, I am taking protein. It will be treated with only HBr. Compulsory we should use medium is nothing but peroxide. Otherwise, it will go according to Marconi curve rule. If you are using peroxide, it is definitely going through anti-Marconi curve rule. So then the things is going according to anti-Marconi curve rule. According to anti-Marconi curve rule, I am telling you, anti-Marconi curve rule is saying the negatively charged particle is added at a higher number of hydrogen atoms having a double bond carbon atom. Okay, later I will explain the mechanism. First you see what is the statement. So here this is the double bond carbon, this is also double bond carbon atom. Here how many hydrogens is there? One hydrogen. Here how many hydrogens is there? Two hydrogens. When we are using peroxide, the things will be going according to anti-Marconi curve rule. According to anti-Marconi curve rule is reverse to the Marconi curve rule. Means the negative particle should be added at a higher number of hydrogen atoms having double bonded carbon. So relatively, which is having higher number of hydrogen having double bond? This one. That's why which particle will be adding? A halogen particle. Why? Because it is becoming like H plus and Br. The negative particle will be adding at more number of hydrogen having double bond carbon atom. Automatically at another carbon H plus particle will be added. Then we are getting which one? CH3, CH2, breaking bond, no, we are getting CH2Br. What is the name of this compound? 1-bromo-propane we are getting. Yes, I will explain mechanism. You see carefully, sir, why happening like this? Why it is going like this? See, first of all, here some things will be going on. First of all, we have to take the peroxide. So this entire mechanism is going through free radical mechanism. I will take one example for the peroxide. It is nothing but benzyl peroxide. What the benzyl peroxide means? C6H5, C double bond O and O, C double bond O, C6H5. Benzyl C6H5. Benzyl peroxide is why it is calling as a peroxide. The two oxygen atoms is directly connected together. Whenever you are falling some sunlight on this one, the mechanism is going through free radical mechanism. You know already free radical mechanism. What is the meaning of free radical mechanism? Bond breaking. Then one electron goes to one bonded atom. Means preferentially this bond will be undergoing a homolytic fission. Then one electron comes to this oxygen, one electron comes to this oxygen. Then we are getting two equal parts. What is that one? C6H5COO radical. Like that one more part. We are getting how many particles? To C6H5, C double bond O and O radical we are getting. I told already yesterday, free radicals are most energetic and highly reactive species. That's why they always want to participating in the chemical reaction. Then what happening? C6H5, C double bond O and O radical. Again it is undergoing a free radical mechanism. Again this bond will be going like this cleavage. Then what happening? Here radical will come, here radical will come. Again you know very well, this carbon has free radical, oxygen has free radical. Two adjacent atoms are having most reactive centers. They are involving in a new bond formation. Then will come here, double bond. Otherwise you see. So what is coming here? C6H5 radical plus C double bond O and O radical here. Yes, no. Already we know adjacent atoms are carrying opposite charges. They will form a new bond. Like that, the adjacent particles are carrying highly reactive centers. They are involving in a new bond formation. Means it is becoming like how? C double bond O and double bond O. It is becoming like CO2 gas. Are you getting on? So this is happening. This thing is nothing but like this. We are getting like this. Okay, let it be. Now what is remaining? Phenyl radical is remaining. How it is happening? You take phenyl radical C6H5 radical plus HBr is there. HBr is also involving in the homolytic fission. Homolytic fission means like this. One electron to hydrogen atom, one electron to Br atom. Then what happening? H atom will combine with this one. Then it is becoming like C6H6 plus what is remaining? Br radical. Br radical is a highly energetic reactive intermediate that will be participating in the chemical reaction with given alkene. How is that one? I will explain. See, this mechanism, just 1 or 2 times practice is very helpful, but it's not important for theory point of view. Okay, anyway, I am taking alkene. Now, what is left in the reaction itself? Br radical is left. Now it is involving in the reaction with the alkene. Take that one CH3, CH double bond CH2. Okay, now what happening? You are taking alkene, what you will learn. Then it is involving in the free radical mechanism now. What happening? You are getting like this. So for example, after breaking you are getting it will be involving in the reaction with Br radical. For example, Br radical will be attacking at a terminal carbon, then middle carbon is becoming a free radical. So then what we are getting? CH3, CH radical and CH2 Br. And also one more possibility, you may feel, sir, I don't want at a terminal, I want to do it middle, do it. What is the problem? We can understand. CH3, the Br will be attacking on middle carbon, the terminal carbon has a free radical. Now my question, it is one type of the radical. Is it primary or secondary or tertiary? This free radical carrying carbon is directly connected with the two carbon. That's why it is calling as secondary free radical. Okay, here the free radical carrying carbon directly connected with only one carbon. That's why it is calling as primary free radical. Okay, you know free radical order? Yes. Okay, free radical stability order as like carbocation. Tertiary free radical is more than secondary than primary. So even though two possibilities is there, which is most preferentially formed? Yes, secondary. Sorry, which one secondary? No, yes, this one will be most possible. This is nothing but majorly forming. Means around more than 90%. Just below 5% will be forming by this one. That's why we are calling as minor. Now both are attacked by H radical. H radical will be attacking here and here also attacking will be possible. Then we are getting which one? CH3, CH2, CH2, Br will be forming. That is only nothing but one bromo propane. That is only nothing but major product according to which rule? Anti-Marconi rule. You are getting this one at middle carbon, but less percentage CH3, CHBr, and CH3. This is against to the anti-marconic of wood. That's why it is forming like a minor product of side product. This is the things will be going on. Don't do the things blindly. Why happening? Why they propose it like that? The reason will be there. You have to go through this one. All of you clear? Yes. Now, I will explain some important things under preparation of haloalkanes. It is nothing but Finkelstein reaction. Or otherwise, we will see some examples for this one. It is nothing but, for example, he given like this one compound. Just application part we will see CH double bond CH2. You are adding a HCl or you are adding HBr. And you are adding a HBr in presence of peroxide. The getting product will be changing. So this is the one type of the alkene. Is it symmetrical or unsymmetrical? Unsymmetrical. Why? Because left side 7 carbons, right side 1 carbon. Then it is going according to which rule? Marconic of rules. What Marconic of rule is telling? Negative particle will be added at lesser number of hydrogen having double bond component, and then getting product will be how 6-membered ring, and on this CH we are getting Br and terminal CH3. And also you are doing same thing at peroxide. Is going according to which rule? Anti-Marconic of rule. What is the anti-Marconic of rule? Negative particle should be adding at more number of hydrogen having double bond component and means terminal. Then we are getting product is like this. CH2, CH2, Br is coming. These only bits. Just I will ask you one more question for you. You see carefully. For example, like this is there. Like this is there. So this is the one of the unsaturated compound. To this you are adding HBr. You are adding. What happening? Or you are adding HCl. You are adding HCl. You are adding. Okay, no peroxide. No peroxide means the things will be going according to which rule? Marconic of rule. According to Marconic of rule, negative particle should be adding at lesser number of hydrogen having double bond component. Check it here. This is the double bond carbon. This is also double bond carbon. This double bond carbon having any hydrogen? No. Single bond, double bond. Over. Balance will be over. Here number of hydrogen will be 0. Here one hydrogen will be existing. According to Marconic of rule, negative particle should be adding at lesser number. So at this carbon, then we are getting which compound? A 6-membered saturated ring. After that, we are getting here chlorine. This is the product. The chlorine should not come here. Why? Because according to Marconic of rule, it should be always attached to the double bond component which is having lesser number of hydrogen atom. All of it clear? Yes. And 3 more preparations will be pending. One is Finkelstein reaction will be there. It is also one of the named reaction is asking in competitive as well as theory examination. So it is also one of the preparation method for alkyl halide. Especially it is for preparation of alkyl iodides. If you want to prepare alkyl iodides, it's the best convenient method. Easily you have to remember Finkel I. Finkelstein reaction is especially for the preparation of alkyl iodides. How it is, I will explain to you, see carefully. If you take any alkyl halide other than iodide, it will be treated with sodium iodide in presence of acetone medium. In presence of acetone medium, we are getting alkyl iodides. We are getting alkyl iodides purity. So what is the statement? Alkyl halides will be treated with sodium iodide in presence of acetone. We are getting alkyl iodides. Sir, you are taking alkyl here, added here, there also we are getting. No, other than iodide compound has to be taken. Means it is generally represented by Rx. Here X will be other than iodide, like may chlorine or bromine. Will be treated with which compound? Sodium iodide. It will be involving in the means medium acetone. What is the formula of acetone? You know, propanone. Propanone formula CH3, C double bond O, CH3. So just you see very carefully, sir, what is the importance of acetone here? Acetone is acting as a solvent. To dissolve which chemical? To dissolve NaI. Why? NaI is having almost covalent nature. Covalent compounds is dissolved in non-polar solvent. Non-polar solvent which is almost acetone. Okay, it's acting as just like a solvent to dissolve the reactive chemical is nothing but NaI. Then what is the possibility? Very clearly apparent. Here X and here sodium will come outside in the form of minus NaX. After that, what is there? Alkyl will combine with iodide. We are getting alkyl iodides. Okay, just I will give you some example. You can get it as CH3Cl will be treated with sodium iodide in presence of acetone. Very clear now. What is happening here? NaCl is undergoing elimination. After that, we are getting methyl iodides. If you take, for example, C2H5Br will be treated with sodium iodide in presence of acetone. Very simple. You have to do so many applications like this. Sorry. Yes. NaBr will be undergoing elimination. Then what is coming? C2H5I is coming. Anyway, Finkelstein reaction is especially for the preparation of alkyl iodides from alkyl halides which are other than iodide compounds. And I will discuss one more named reaction for the preparation of alkyl halides. It's nothing but Swarts reaction. Swarts reaction. Swarts reaction also has some special. It is especially for the preparation of alkyl fluorides. Highly reactive compound. Why? Because fluorine will be there. That's why this preparation is not that much easy. That can be prepared only by using one of the named reaction is nothing but a Swarts reaction. So we may ask a question, one more question. To prepare alkyl fluorides, what is the named reaction? Swarts reaction. So what is the thing? Same thing. Just you see carefully. Alkyl halides. Alkyl halides will be treated with the metal fluorides. Metal fluorides. Then we are getting which compound we are getting? Alkyl fluorides we are getting. Alkyl fluorides we are getting. We are going to use any solvent. Why? Because fluorine compounds is highly reactive chemical. Yes, just add reactive molecules. So we are going to use any special solvents here. So alkyl halides is generally represented by RX. But here X is main chlorine, bromine or iodine. Other than fluoride compound has to be taken. It can exist. Why? Because reactivity will be less. Okay, it will be treated with metal fluorides. So what type of metal fluorides can be used here? You see carefully, silver fluoride. Or we can use mercurous fluoride, Hz2F2. We can use some other metal fluorides, cobalt fluoride, CO. While writing CO2, we take very careful. Why? Because CO should be written like this. You are writing both the same sides, carbon monoxide. Or otherwise, we can use antimony fluoride, CBM fluoride. We can use any one of them. Automatically, what happens? Halogen will combine with silver or mercury and come outside, and which will be undergoing substitution over there, fluorides. Then we are getting which compound you are getting? RF we are getting. Are you getting? Just I will give you one example. You see carefully. For example, CH3Cl will be there. CH3Cl will be treated with which one? Silver fluoride. What may possibility? The silver and chloride will combine together, and automatically what products we are getting? CH3F we are getting. Like that, if you can see one more thing, C2H5 Br you are taking. It will be treated with, for example, Hz2F2, mercurous fluoride. You can use that one also, it's not a big thing. But if you want to react, compulsory you have to take 2 moles. Then only what happens? 2 Brs combining with 2 mercury. It is becoming like which one? Mercurous bromide, Hz2Br2 coming outside. The 2 bromines is occupied by fluoride. Then we are getting how many moles? 2 moles of ethyl fluoride we are getting. It's a very important thing. Just I will give you some extra point here. Observe carefully. If you want to remove from same carbon to halogen atom, compulsory you have to use some powerful chemicals in nothing but cobalt fluoride or sodium fluoride. Just I will give you example you can understand. For example, CH3, C, Cl, Cl and CH3. So one type of alkyl halide is geminant halide. jump dihalide. Why? Because both the halogen lying on the same component. It will be treated with which one? Cobalt fluoride. Then compulsory reaction will be possible. But this reaction will not possible with these first two chemicals. Why? Because they are relatively less reactive. But what is our work here? At a time we have to replace the two halogens from the same component. Then we have to use a powerful reagent, that is nothing but cobalt fluoride or sodium fluoride. What will be happening? You can take 3 moles here, you can take here 2 moles. Means each molecule has 1 chlorine, 3 molecule has 3 2s 6 chlorines. 6 chlorines will combine with the 2 cobalt, it's becoming like 2 moles of cobalt chloride. Now what happening? Chlorines are replaced with the fluorine atom, then we are getting CH3, CF and F, and here CH3. We are getting how many moles? 3 moles. Cobalt. But the condition is what? From the same component at a time, if you want to replace more than 2 halogen atoms, should use some special and powerful reagent, cobalt fluoride or antimony fluoride. And last method for the preparation of alkyl halide is nothing but Hunsdiecker reaction. Hunsdiecker reaction. Yes, most of the times we ask in complete examination. What is the Hunsdiecker reaction? We have to take the silver salt of carboxylic acid. Silver salt of carboxylic acid. Carboxylic acid will be treated with halogen like Br2 in presence of non-polar solvent CCl4. CCl4 means what? Carbon tetrachloride. Then we are getting alkyl halides. Alkyl halides, we are getting some other side products is also coming, we will get it. What is the statement? Whenever silver salt, Hunsdiecker is nothing but silver salt of carboxylic acid will be treated with Br2 in presence of carbon tetrachloride. We are getting corresponding alkyl halides. Okay, first of all, what is the meaning of silver salt of carboxylic acid? You know the functional group of carboxylic acid. What is that one? RCOOH. This is the functional group of carboxylic acid. Silver salt. Silver salt means what has to be done? This hydrogen can be replaced with silver. Then we are getting which one? RCOOH. We are getting, that's what we are calling as a silver salt of carboxylic acid. I am writing that one over here. RCOOH will be treated with which one? Br2 in presence of carbon tetrachloride. It is a non-polar solvent to dissolve bromine. Why? Bromine is also non-polar. This is also non-polar. We already learned in solution like dissolves like. For the purpose we are using that one. See, in organic chemistry we are using something means it has some particular action in the chemical action. Simply we are not using whatever you want. Okay. Now what happening? Very clear. One alkyl group is combining with one bromine. It's becoming like RBr. Okay now? Plus one silver will be combined with one bromide. We are reading which one? Silver bromide. Plus one gas particle will be producing. What is that one? CO2 is forming. And Az here is becoming like a precipitate. And this is becoming a liquid. Separation will be very easy. Whatever CO2 is there going escaping and silver bromide becoming precipitate, and whatever you want that will be liquid. We can filter it and we can get it. Okay, can we see some examples for this one? For example, silver salt of acetic acid will be treated with which one? Br2. Yes, sir. By seeing this one, you have to understand. Okay, this is similar to silver salt means Hunsdiecker reaction. What happened? You have to get it. You will get it by practice. So, in presence of CCl4, then what we are getting? Alkyl combining with Br, you are getting a CH3Br, plus you are getting a CO2, plus you are getting a AgBr. Can I give you one more question? You can take like this, if you take COOH, silver salt of cyclohexane and carboxylic acid, and in presence of Br2, same thing, you should get it. It's a Hunsdiecker reaction. Here CO2 coming outside, it is becoming like alkyl. So we are getting directly connection to this one halogen. We are getting a bromo cyclohexane we are getting. Yes or no? Yes, after that we are getting CO2 and we are getting AgE. So very important concept. Under this we learn so many named reactions we learned under the preparation of alkyl halide, Groves reaction, Dodgen's reaction, and after that Finkelstein reaction, especially for which one? Iodides, and Swarts reaction for especially for fluorides, and one more named reaction, Hunsdiecker reaction. There we are getting halogen alkyl halides we are getting. All of you clear? Yes, this is information regarding preparations. You have to practice carefully. Yes. Okay. Just based on these preparations, I will ask some competitive bits you can understand. See carefully. For example, CH3, CH2, CH2OH. So will be reacted with PCl5. What is the product? You have to understand, okay, this is the preparation of alkyl halide. Yes, it's not told from alcohol by reaction with phosphorus halides, we are getting alkyl halides. Should get that much practice. Okay, then what happening? One alkyl group immediately combined with chlorine. We are getting which one? CH3, CH2, CH2, Cl. We are getting plus. Side products is what? Phosphorus and oxygen and 3 chlorines. Is becoming like POCl3, phosphorus, oxytrichloride, plus one more is nothing but HCl. In organic chemistry, the balancing is not that much important. Products is very important. But in inorganic chemistry, balancing is very important. You have to keep very carefully in your mind. And later you see some other things I want to tell. For example, CH2, double bond CH and CH3. It will be involving in the reaction with chlorine in presence of CCl4. What happened? Addition reaction will be going on. It is also preparation of alkyl halides. Yes, unsaturation is there. Unsaturation is there means they are involving in the